So in this situation, we have three different right triangles. If you notice with the first triangle, we have a side length of 30 units and the hypotenuse length of 50 units. So in this case, we're trying to find x, which is the length of one of the sides. And so we could use Pythagorean theorem to solve for x. Pythagorean theorem works when you have a right triangle and you have two side lengths and you're trying to find the third side length. However, in number two, we do still have a right triangle and we're trying to find the side length, but we have a side length and an angle measure, and so we couldn't use Pythagorean theorem to solve for x. Luckily, in this case, this is a special right triangle. Do you see that we have 45 degrees here? By triangle sum theorem, we could figure out that this angle right here would also have to be 45 degrees. So this would be a special right triangle, so we could find x. And if we had a 30, 60, 90 triangle, we could also solve for x. So to recap, if you have a special right triangle and you know that one of the angle measures and a side length, you can find the missing side length. And number three, we also have a right triangle. We know an angle measure, we know a side length, and we're trying to solve for a side length, but we can't use special right triangles in this case because it's not a special right triangle. We have an angle measure of 20 degrees, and this other angle measure would be 70 degrees. And so we can't use Pythagorean theorem or special right triangle relationships to solve, which means that we need something else, something new to help us solve for a new case. And so that leads us into something that we're going to talk about today, which is called trigonometric ratios. So trigonometric ratios are dealing with trigonometry, right? Trigonometry actually is the study of triangles, and ratios just means you can write like some numbers as a fraction, basically. And we use trigonometric ratios to solve for a missing side length of a right triangle when we're given a measure of one of the acute angles. So that's an angle that's between 0 and 90 degrees, non-inclusive, and one of the lengths of the sides. So basically like that number 3 problem. And so there are 3 different trigonometric ratios we're going to talk about, but before we get to them, we have to learn about opposite, adjacent, and hypotenuse, how we would name the sides. So when we're dealing with trigonometric ratios, we're going to have a reference angle. And the reference angle is going to help us figure out where the opposite side is, where the adjacent side is, and where the hypotenuse is. So if you look at this example, we have an angle right here that's represented with this letter. That's actually a Greek letter called theta, and that's what we often use to represent an angle measure in math. So we just want to practice stating where the opposite, adjacent, and hypotenuse sides are based on our reference angle. So looking at this reference angle, the side opposite to that is directly opposite. So again, we can see that our angle measure is completely on the opposite side of that angle. What I typically like to do next is to figure out where the hypotenuse is, which is always opposite of our 90-degree angle. So we have our 90-degree angle, directly opposite, we have our hypotenuse. That always happens. And then the last side we haven't labeled is our adjacent side. I find that labeling the adjacent side is often trickier for students just learning out or learning the topic. So we would find our opposite, find our hypotenuse, and then we have the adjacent left. Adjacent sides are going to be the side that forms the angle that's not the hypotenuse. So if you notice in this picture, we have the adjacent and the hypotenuse, and it creates our angle. But the adjacent side will never ever be the hypotenuse. So again, we have our opposite side is opposite the angle, the hypotenuse is always opposite the 90-degree angle, and the adjacent side is the side that forms the angle that's not the hypotenuse. So we're going to have 3 trigonometric ratios that we're going to deal with in Math 2. The first one is sine, the second is cosine, and the third is tangent. Note that we do have reciprocals to these ratios, cosecant, secant, and cotangent, but we're not going to deal with those in this math course, but you will see them in your upper level math courses. So these trigonometric ratios that we're going to talk about are only for right triangles. So if you have sine, you're taking the sine of an angle, and the sine of the angle will give you an actual number, and that number is going to be the same as the ratio of the length of the side opposite that angle divided by the length of the hypotenuse. So if you take the side opposite the angle divided by the hypotenuse, that's going to give you a number, and that number is equivalent to the sine of your angle measure. And so there's several ways you can look at it. This one gives you just like the full out definition, A lot of times students will just write sine of theta is equal to O over H, where O represents opposite and H represents hypotenuse. So here's two ways you might see it. So we have our opposite and our hypotenuse, and we have our opposite and our hypotenuse. Again, make sure you know the hypotenuse is the side opposite the right angle, okay? But the opposite side is opposite the reference angle. So make sure you understand that distinction. Our next trig ratio is cosine. And so if you take the cosine of an angle, that gives you a number, which is equivalent to the length of the side adjacent to theta divided by the length of the hypotenuse. So we have cosine of theta equals adjacent divided by hypotenuse. So you have your hypotenuse, which is opposite your 90-degree angle, and adjacent is adjacent to the reference angle. And same thing in this picture. You have the hypotenuse opposite the 90-degree angle, and you have the adjacent side forming this angle that's not the hypotenuse. The last trig ratio we're going to talk about is tangent. So if you take tangent of theta, that's going to be equal to the length of the side opposite theta divided by the length of the adjacent side to theta. So you get tan of theta is equal to O over A. So you have your opposite side divided by your adjacent, and that's going to equal a tangent of whatever this number is. And theta would be a number, just like your opposite and adjacent sides would be a number. Again, you have your opposite and your adjacent sides. So here's just a bunch of color coordinating. If this helps you, it may not. A lot of people like to think about SO, CA, TOA. And so oftentimes when I was in school, I would just literally write down SO, CA, TOA on my paper just to help me remember, like, you have sine, opposite hypotenuse, cosine, adjacent hypotenuse, tangent, opposite adjacent. And so we have it color coordinated here. This was a story that my teachers taught me when I was in school to help me remember. I am not advocating for this at all, but it may help you remember SO, CA, TOA. And then over here is just the same stuff you just learned on the previous sides, just with some color coordination going on. Please make sure that you know that trig ratios are only used for right triangles, and your reference angle will never, ever, ever be that right angle. Your reference angle is always one of the acute angle measures. You will see sine, cosine, and tangent in a lot of different ways throughout trigonometry, but these ratios are only used for right triangles. When you're doing your problems, you need to make sure that your calculator is in degree mode. There's another mode called radian mode, and that's something that you'll use in your upper level math courses, but we're going to only be dealing with degrees in Math 2. So you're going to want to press this button mode. It's next to the second button. Once you click it, you're going to see this screen, and you're going to want to go down to radian and scooch over to degree and hit enter to make sure you're in degree mode. Note that if you ever reset your calculator, clear it, whatever, then you're going to have to re-put it into degree mode. So make sure that, like, on your final exam, when they change your calculator, like reset it, that you immediately go and change that back to degree mode. And then in your upper level math courses, you'll just have to make sure you know when you should be dealing with radians and when you should be dealing with degrees. Also, you need to make sure you know where the buttons are for sine and cosine and tangent. And so if you look at your calculator, it's to the left of the caret button and next to x to the negative 1. So you have sine, cosine, tangent. So let's practice. In this example, we have a right triangle, we know an angle measure, we know a side length, and we're trying to find a side length. So what I would initially do is to write out all the information that I know. So I know that theta is equal to 25 degrees. That's going to be my reference angle. And then I want to figure out if I know anything about the hypotenuse, the side opposite my reference angle, and the adjacent. So I would write my reference angle. I don't know anything about the hypotenuse, so I'm just going to scratch that out. We know the opposite is going to be x, so that's what we're solving for. And then we have the adjacent side is 12, technically inches. So from here, I want to think about SO, CA, TOA and figure out which trig ratio is going to help me solve for x with the information that I have. So I don't know anything about the hypotenuse, so that's not helpful. So sine, I have to know the hypotenuse. And same thing for cosine. So I don't need to use either of those, which means that I need to use tangent to solve for x. So tangent is going to be a tangent of your reference angle, and in this case, that's 25 degrees, is equal to x over 12 inches. So now I just need to solve for x and then type that in my calculator. When you type this in the calculator, you won't be putting in inches or the degree. You would just type 12 times tan of 25, close your parenthesis, and hit enter. And when you do that, you're going to find that x is approximately 5.6 inches. If you feel like you typed everything in correctly and got this answer, make sure you're in degree mode.